1, 2, 3. Live.
Well, hello everyone. Thank you for joining us today in our 12 vvvv meetup. We do this every month. I'm your host for the night. My name is Randall, and I'm here with a lot of lovely known and some new faces who have already joined us on this Zoom call. If you're not familiar with what we're doing tonight, it's a very informal kind of bring your own work and share with the community type of meeting. So if you want to join us, you can do so by joining our Zoom call. If you want a better resolution and a real-time type of experience and you want to interact yourself, maybe ask some questions or make some comments, you can join us on the Zoom call. You can find it on the forum post with which Amir, who is helping me today. Thank you so much, Amir, in the controls. We'll be posting soon on the chats. It's also on the forum post. You can join us there live on Zoom if you want to participate. If you just want to watch from your couch and be a more of a passive participant, you can also join us via the YouTube stream, which is live and up now. You can comment there. You can leave us comments on our Element chat as well. And of course, if you're joining the call, you can just comment yourself live. So thanks again for joining us. And let's first start by saying hello to the people we have here. And maybe guys, we do a quick round, who you are, what you're doing here today, if you're showing us something or just join in for the conversation. And yeah, let's start with that. So how about Bersun? What's going on with you today?
Hello, everyone.
Yeah, so Christian, I'm here on behalf of the Fuse team. So hopefully Kyle is joining on later and we give you guys some update on Fuse. Yeah.
Cool, thanks, Chris. Now, Bersun, if you will.
Hello. Well, you know, vvvv fan. I'm happy to be here. I'm showing nothing today, just watching.
Amazing. Alvaro?
Yes, hello.
Beautiful dog.
Yeah, I'm Alvaro and my dog. Yes, I'm AK Visuals in vvvv webpage, and I will show you today some of the stuff I was working in the last times that it was about like shader effects and the Megascans importer for Gamma.
Cool. Hayden? Hadassi? You are muted, Hayden, so we can't hear you.
Hello, of course, I'm Hayden. I was just going to just talk a bit about something I'm doing with Stride, kind of character bony stuff. Just going to like show you it and sort of ask some questions about it. Yes.
Cool, great to hear that. Sevis Kudi, lovely to have you, by the way. Welcome.
Thank you.
Are you showing us anything today?
Yeah.
Or are you just here for the fun? Oh, cool, nice. What will be seeing from you?
I'm going to show ML.NET Model Runner.
Beautiful, exciting stuff. All right, great. Mr. David Brul, who is also lending us the infrastructure today on behalf of the Node Institute. We're very, very thankful as always. David, are you showing us anything today? Anything to share?
No, I'm here to hang out. As usual.
You're very welcome, as usual. And Kevin Brack, hello, welcome. We can't hear you. I think you're muted. Well, we lost him. Technical difficulties, that's fine. I imagine we're going to have a few other people joining as we go along. And again, the invitation is extended to all of you at home to join us. If you have anything to show, anything to share, you know, it doesn't need to be fancy, flashy, and super sophisticated. It can be anything you've been working on, or maybe a question, maybe an interesting fail. We're more than happy to have you and listen to what you have to say. So, like I was saying before, we're expecting more people to join today, but let's see how it goes. For now, let's start, I would say, let's aim for 10 to 15 minutes each. to keep it kind of going in terms of the presentation, and then we do a bit of questions at the end, and then we move on. So without further ado, any volunteers? Anyone want to take the first go? Okay, Hayden, I saw a hand up, so walk us through it.
Okay, cheers, thanks. Okay, I'll just share the screen, suppose then. Share screen, start share screen too. Okie doke, sharing. Cool, I don't know if you can see the screen now. Hope so. So basically recently I've been working on this ways to basically transform characters directly inside of Stride. So one of the things is, was kind of like wanting to kind of like get characters in, get to do stuff with them. I know that you actually run animations with them. I think it's already been demonstrated by Tebian previously. But I was at a point where I was like, okay, I would like to sort of do a bit of puppetry with some of these characters, and I need to kind of at least the first step of finding out how to do that. So what I did is currently also available in the work in progress, but what I basically made was this thing that's called strideskeletons projects. And what I have is a few examples, which I'm putting up here. Problems. If anyone has any problems opening these up, by the way, do let me know. So let's bring it over to the first one first of all. This has got like the most obvious kind of way of working. So what this is a model that I imported into Stride Studio some time ago, and the challenge for me was to basically work out, okay, how do I get this thing to then have all of its bones basically be kind of like adjustable within 4V, within our environment. At the moment, there isn't a way that I could import this model directly, and then kind of like take the skeleton that's within the model and then start to manipulate it. But for the time being, I have to basically go through importing the actual project itself, because within the project, that's basically where you kind of fuse the model with the actual skeleton. And then you've got choices as to whether you want to animate it directly from an animation clip, or if you want to just do what I'm doing now, basically, which is manipulate the actual bones. So quickly just showing you how the bone art actually works. So you look down here, or a quick run through in general. The first one that I have is the actual model, the model asset, shall I say. You can see it there. And funny enough, see it like that as well. You actually see, I think it's actually changing over time. So, anyway, the important thing is that you can take this out. It has a skeleton inside of it already. And because it's got the skeleton already built into it, what I then did was I basically made this thing, which allows me to actually create a new skeleton using the previous skeleton's data. So what I then do is I pass that down, I create this secondary skeleton, which is probably going to crash now. Of course it will. There we go. Right. Get back again.
Not a demo if it doesn't crash, so we're on the right track.
Thank you very much. I mean, I don't want to admit that.
Sunit was asking if you can bring your microphone a tad up, Hayden.
Yeah, sure.
I don't know if that's an option.
I may have to just shout a bit louder. It feels really weird. I basically spent all day kind of like duck, what they call what's called duck debugging, which is basically where you talk to a random object or to yourself about the thing you're trying to fix. So the idea that I'm now going to speak aloud in an empty room again is a bit weird. You just mutter it under my breath, but there we go. Okay, so let's bring this back across again. Right, cool. So as I was saying, let's get rid of that one. Do it. And then this one again. Okay, cool. So basically what happens is I basically create a skeleton from another skeleton, whack it into the model, and then I can start to actually play with it like in real time, so to speak. So all this is here is we have this thing called the actual setup. That basically takes the skeleton, basically creates the parts for us. It also outputs like the number of bones. It outputs the actual bone names or kind of things that relate to the bones. The actual parent ID, which is actually pretty handy or pretty important for what I think I want to do next. And also all the matrices themselves. So that could also be handy in time. So what happens is that if I just remove this for the time being, you see that what's going on is that we're not actually setting the actual matrices for this thing. We just transform or manipulate the matrices that are already inside of this object. So if I were to basically just make a quick transform, these, gosh, just for argument's sake. So we have there. So basically we have there basically the actual bone itself, and we can just manipulate that as we wish to. And of course you can basically apply this to all the ones you've basically got in there. And so yeah, you can basically apply this to all of the bones you've got in already, including being able to do things like this, which is to actually transform them, take them away from the body as well. So all of that's kind of built in, and it can do with things like choose different parts of the body that you basically want to manipulate as well. They're all there and available. And if you basically have like, so if you basically were doing this with all of the bones that you basically want to do, then you could literally just make them all fly around and do weird stuff, which I've done previously, but I'm going to do right now. So what we can now kind of move on to, I think, is this second part, which is basically being able to actually animate these things, and it kind of gets to the crux of my particular interest or issue. So let's just do it like that now, right? So here's a character rolling around, looking tough as anything. Right. The thing I want to do with this is I want to actually take these bones and do stuff with them while the characters are being animated, ideally anyway. And to do that, what I want to be able to do is get this matrix, but this matrix currently is not correct. I'm pretty certain that you can see I've been trying to do a bit of debugging and finding stuff and so forth. But there's some way that I should be able to get what is called the animation clip. So first of all, you have this animation clip is basically built into the actual clip itself. Actually, we just quickly go back for a second then. So we have this asset, and because again within the Stride Studio, we basically we create this animation. We don't have to actually animate it. We just need to basically set the animation up inside of Stride Studio. Then we have to do this thing here, which is called animation asset to component. The idea basically is that we find the clip that is actually inside of the Stride project, and then we basically whack it into an actual component. Once it's actually a component, then it can be a component of the entity, and then we can actually start to play around with it, manipulate it. So this animation processor that we have here, all it really does is it basically just takes the animation and allows us to basically do things with it. So in this case, I basically play through the animation and like basically choose like what kind of repeat mode I want to have for it. Obviously, in this state, what we probably want to be able to do is to actually move it around and change things up. So this is going to come to that in a second. No, I thought it was only 5 minutes, but it seems to be maybe a bit longer. This one. Okay, so here's another one. The difference with this one is that if I start to actually play with it, it will play. I'm going to put it on hold. There. What I'd like to be able to do is to not only have it just kind of like, you know, walk, but to be able to then basically, like say, like raise the arm while it's walking or making around and stuff like that. And I can kind of see two potential ways of doing that. One would be that we get this animation data from here. We apply it directly to the model as we wish to, like basically like when we look at like we're overriding the model as it's basically being animated. And I think if I look in here, there might be a clue as to how that should work. Maybe transformer. Okay, in here. So you see that I've got this thing here that basically override max and transform and so forth. This, from what I understand, is how you can actually change the nature of how the interaction works. Like whether you're basically just transforming the model, or if you're actually kind of like updating the animation. So you should actually be able to like mix and match between those two things, the actual matrix itself and the matrix that you basically want to transform it with. I haven't quite figured it out yet, but it shouldn't be too tough, I don't think. The last thing I'll show you is this one, which is my current bane of existence. What this is an animation based upon Kinect. So if I play through this one, Okay, yeah, as usual, as you do with these tech demos, this is what happens. Okay, right, so maybe just play this thing through. So, oh, yeah. That's better. Okay, right. So this huge mess that we can see here, basically, is this animation that we're trying to make. So if you run this now.
Ah, look at that.
Yeah.
Is that you doing macro?
That was me. Yes, I'm afraid to say that was me doing a minor performance for the sake of yeah.
Nice.
Thank you. But yeah, so the idea essentially is that we should be able to play this one. So this is basically the actual Connect, the real Connect doing its thing. And these are some bones that I've basically constructed from the input of this Connect. So you can see this guy coming in here. You have the skeleton, although you can't see at the moment. You have all these joint positions, which is the important part. And you also have the conterniums, which define direction of each of these bones in terms of like their general alignment. I just used that to this basically create this this little bone visualization. But what you also see this animation going on, and this animation is actually coming from Stride itself. So if I were to maybe stop this animation, but I need just to play once, which should stop in a second. It's quite a long animation, but it will stop in a little bit anyways. And then what I'll be able to do is actually start to play around with the rotations that are basically going on inside of it as well. Okay, oh, there we go. Okay, right. You can see this little weird behavior it's doing at the moment. Okay, so you can kind of see at the moment I'm basically trying to rotate one bone. And what happens is it kind of basically just sort of flails out and does all sorts of weird stuff. And this is the thing that I need to try to actually fix. It's this part, to get from this to this, by understanding how the rotations and how the actual tree of bones is basically going to be kind of set up. So what I'd like to ask you guys out there is, one, who else is interested in actually figuring out this issue? I spent some time on it. I probably could spend more time on it, and I could probably take some more hints and stuff, but I can't spend too long on it because I do have other things to do. But in general, I just want to know if anyone is actually interested in this particular subject. I'd like to pull some of the knowledge and information from people that are already trying this, maybe have already succeeded in doing this or whatever. I feel like I've kind of set up a nice base in terms of the actual manipulate the bones, and also other ideas about how this could be approached. Like maybe it doesn't need to be done with directly with a Connect in this way. Maybe it could be done with something completely different. Maybe it doesn't have to be direct rotations from the Connect. Maybe it could be based upon IK or something like that, which I'm going to also start to experiment with. I've got a little something working with IK, but I haven't implemented it inside of this system yet. So that might be something that I'll try to do in the future. But yeah, but anyone who's actually interested in helping out or just basically giving me a shout and saying that this is something you're already interested in, then myself and my company are very interested in what we might be able to do with this. So the more people, ideas, skills we can pull, the better. Potentially even like a little, maybe like a little like egg nest of money or something. I don't know, because who's interested. But yeah, so let me know on that basis, I think.
Absolutely. So if you're interested in all things skeletons and going from one skeleton to another and animating them and controlling them, which is a universe of its own, Hayden is undertaking that project, and he very much wants your or our help. I know you've been making some conversation in the Universal Skeleton Bible channel we have in Elements, so there is already kind of a space for discussion on this. But if you're not part of that yet and you want to be part of the conversation, reach out either to Hayden or to me, or just on the general Element room, and we'll point you in the right direction.
Exactly, the Element room, and also I think there's also a forum as well with the Skeleton Bible too. So I think any of those places would be awesome.
Yeah, amazing, man. I mean, so just to see if I got it straight, this would enable me to not only have an animation that's already being pre-rigged in, you know, Cinema 4D or whatever. But I could also intervene, like kind of hijack part of this animation. So for example, I could have the Kinect mapping the top of my body to running animation that comes from somewhere else and kind of combine them. That sounds super powerful.
It's still getting there, but it will be there, I think, pretty soon. Exactly, yeah.
Yeah. Next week, I heard. So
you heard.
no, very exciting. I don't know, do we have any questions or comments for Hayden from the people in the audience, or maybe somebody in the Zoom call right now? I find this very interesting and fascinating. I spent quite some time myself fighting skeletons, and I am very much interested in helping. I just don't have a lot of time right now, Hayden, but at least in spirit, I'm with you. And yeah, fascinating. I very much appreciate the effort and the progress you've made already.
Thanks.
Yeah, getting amazing from Han Tu, who is here on the call, who I don't know yet. Maybe we'll get to hear from him or her in a minute. Yeah, cool stuff. So good comments all around. Thanks as always for sharing amazing stuff. And yeah, keep an eye out for Hayden's skeleton adventures, and please do help if you can or feel like it. All right, cool. Amazing, thanks, man. If you joined us recently, so that was Hayden showing us his progress on skeleton work in vvvv. If you just join us or you don't know what's going on, we're just showing our work. People are joining casually. There's no specified agenda. You can join yourself. We have a YouTube live stream. The link is on the Element chat and on the forums as well. And we have the Zoom call open if you want to join us and participate or show us what you're doing or just join the conversation as well. That is also linked in the forums and in the Element chat. So please do join us. I forgot before I send Hayden in that Amir is also showing us some things today. So looking forward to that. I saw a sneak peek and it looks very, very powerful. Also, I saw Christina join us and also Han1. I don't know if you want to say hello. Hello, Christina. Good to see you. Welcome as always.
Hi, good to see you.
Are you going to share anything with us today?
No.
All right.
I
That's
just like
cool.
to hang out with you.
No, we always
Almost
like to have you
impressive.
around. And
Hi,
Han,
everyone.
very welcome. Hi.
Yes, hi, I'm a student from Christine, and I took part in her workshop and her class for Gamma, and I would later maybe show something of my project, my first ever for project.
Amazing. Thank you so much for joining us and already bringing something to show. That's great. We have some other things to go through as well, but yeah, we're very excited to see. And can you tell us a little bit, maybe give us a sneak peek on what we'll be seeing from you?
It will, also, I worked with Skia and made a kind of audio visualization, and that's what I'm showing. It has, I was aiming for a sci-fi look, so yeah.
Okay, sounds very exciting. Amazing. Okay, cool. So does anyone else? I'm gonna just start pointing fingers. Alvaro. Oh, sorry, Amir.
No, I was just thinking that since Hayden was talking about like transformation and like sort of like joints and skeleton and stuff, I would just jump in because it's not that much unrelated. And
That's
then
true.
also then I could be like more focused and helping you looking at the comments and stuff. Right? Would that be okay?
Yeah,
cool.
Absolutely. Makes perfect sense.
Let me share the screen. That should be this one, and I don't need the audio. Good. Are we good? Do you see my screen?
Perfectly. Yep.
Cool. Yeah. So if you remember in November last year, I was showing this little utility, little tool for animating robotic arms, and it was just basically I was just showing this forward kinematics, that how could you control the individual axis of a robot from the base and from basically from the base onwards, like from joint 1, like A1, A2, and so on until the flange. And today I want to show you like a bit of development here. And I want to show actually a project that, an artwork that we did for the Ars Electronica 2 years ago through Kunstuniversität in Austria, in Linz. So first I just show a bit of like technical stuff, and then I will jump to show some videos of this project that we did. We updated it basically for the museum. So I think you see this little sphere there, like with this tiny axis. It has its own coordinate system. So if you see, like I'm just like trying to move it around, it's like super simple. It's just like moving it like to this 3 direction X, Y, Z. And what is I'm very happy to see this, and I would like to do that here as well. So just what if we just put a robot behind it, and then without even thinking of what is what basically what is the rotation or for each joint, which was the forward kinematics. We don't care about that. And then because we have this algorithm that takes care of that. So basically when I just move this sphere around in X, Y, and Z, the solver, the IQ solver, just basically takes care of calculating the correct rotation for each joint. And then also, for instance, if I go to a position that this position is not possible for the robot to execute that, it just basically shows which joint is reaching its limit. And so it's basically that is a inverse kinematic. So I just don't care about whatever is happening to the body of the robot, the linear skeleton of the robot. It will be taken care internally. So everything is basically like, yeah, everything starts with this XYZ coordinates, and then this part that you see here, that, I mean, if I zoom in, doesn't really show that much, is basically the PRC inverse kinematics is the courtesy of the robots in architecture. PRC is the tool within Grasshopper environment. This is the department that I'm working at the Creative Robotics at the university here, and that is the kinematic solver that they wrote for Coca PRC. And basically, you can think of any other robot here. You can think of many other robots there. Technically, anything that KUKA has been producing since their beginning of career, you can simulate them, you can control them, and you can animate them. Of course, using Coca PRC in the environment of Grasshopper in Rhino, and by now also in our beloved vvvv Gamma. So for now, we are just using it internally because, of course, things are way more complicated when you see an actual robot moving in front of your face. So there are a lot of things that they have to be, like, I don't know, debugged, and they have to be taken care of, and that is basically my take. But just for the sake of conversation, just connect this our sphere to a Wanderer, and then you see that basically it's just the kinematic also works in real time. And then the good thing is we receive, like afterwards, we receive this each axis, the correct rotation for each axis, that then in real time we can send it to the robot. So basically, in whatever you see here, if there's an actual robot, in this case it's an Agilus 10, then basically you can just expect the robot to do exactly similar behavior and position. So I just want to make it quick because I know that there are a lot of people going to present today. So I just want to jump into the project that we did 2 years ago, which was it's called Pinocchio. It's in the Ars Electronica Museum. This video is really fresh, and I wasn't prepared, to be honest, to just show some proper video. So it's the courtesy of the Ars Electronica YouTube channel that they had this like virtual tour, or like this live stream. So we did this project. It's called Pinocchio. We did this 2 years ago, and then we basically motion captured a professional puppet player. And then we use that data to make a set of sequence of dance or choreography for the puppets. And then afterwards, we convert those data to robot movements, to the linear skeleton of the robot. And then the robot, they were like basically playing. You could just go there, press a button, and you could see a choreography being played as the audience. But then with this basically setup, and with this update, we grant control to the audience. And if you see on the ground, there are these two markers, like one of them is under my feet. People could could just go there using their phone, the browser of their phone, their cell phone. You just go to the browser, you go to this URL, and then you point your phone to one of these markers. And then when you're connected to this very IP address, basically you take control of each robot, and then in real time you can control them. And then you should hold your phone as if this is the sort of, you can think of it like as if this is the control bar of the marionette. And then the robot in real time mimics that behavior. So basically you are taking control and as if you are a puppet player. I just want to quickly show a, because I think here I'm just like trying to, I'm explaining.
Don't worry. Yeah,
okay, cool.
No.
That is it. I'm just trying to connect to the server right now. And then as you see, there's also like a tiny visualizer down there. And these boxes that you see there, also they are the working area of the robot. So we just want to send the data from the cell phone to the robot only if the robot is in a safe area. So if it's not in a safe area, we just ignore the data and we don't send anything there. So it's like a first, like the first element of having like a safety environment. And of course, from the robot itself and the controller, we have another step of having safety. And also, again, there is a laser curtain in front of the robot. So if anything tries to reach the robot, they immediately stop on the emergency stop. And the cool thing about this is like, which is like, we really like it. And in the department, this is something that we are basically working on. This project and this development is led by Professor Brauman as well, who we are really pushing this idea of remote control and remote presence. So basically, when we think of like having a cell phone and connecting through the web browser, controlling the robot, doesn't really matter if I'm standing in front of the robot or if I'm, for instance, in Amsterdam and the robots are in Linz. You know, so it's basically you can be there and you can interact with the robots. And the cool thing is, I think it is cool. I hope the others also find it cool. That it's just not you are pressing a button or you are triggering something, because you see the feedback, and you know that, and then through time you learn that if you do this with your phone, that will happen. If you do this, that will happen, and then you basically exist within the interaction. And I think this is really cool because it has a learning curve. Like for example, for me, it was in the beginning I was like, oh, okay, I don't get it. But then the more I was trying it, I was like, oh, okay, now I think actually I can do some movements, although I'm not a puppet player, right? And I think it's really cool. Yeah,
Amazing.
That was it.
Wow, Amir, you really sped through something that is amazing and beautiful.
Yeah, sure. I mean, I have like, this is something I have to say that this is a work of a group of people at the Creative Robotics department at university, and of course I'm standing on the shoulder of giants. Is it how I said? Yeah. Cool.
How was the interaction in terms of lag? Do you have a lot of latency between your movements and the actual robot movements in real time?
So the latency, basically, it is of course nothing is like absolutely real time. Basically, like whatever you do on Windows, you have like a few fragments of a second latency. But I think what is really important in interaction real time with robots is, first of all, it's a path planning. That is a very important thing. And then second of all is like, it's very important to be careful about the motors of the robot. Basically, you don't want to jog it like back and forth. So there are a lot of smoothing algorithms in between that it is very crucial to just think of it as a path that you are creating, not as a constant feedback and reaction, because that is not the goal. You know, like you need to create a meaningful interaction instead of just, I do this, it has to immediately repeat that. You know, I think it's more like not that much of a technical issue, but more of a conceptual issue, to my understanding.
I mean,
sounds like you're building a dance piece almost.
I mean, one question, like when you control the robot in real time, then you actually sending the data for each of the individual axes, correct?
That is one approach. There are two approaches. You can send what we call TCP. It's like a tool center point. Basically, like whatever is mounted on the robot, and it's an XYZ coordinates. And also, like you have an XYZ and also the orientation for ABC. Like for instance, like if you look at here, like we are approaching the sphere from its back, right? So if I just change the and and now I'm approaching it from the other side, right? So basically this TCP, which is the center of this sphere, has one XYZ and an ABC. That's one approach. The other approach is like, yes, sending the access values to each access.
Okay. So in the one case, the inverse kinematics is done in vvv and you control the axis. And in the other case, you're sending a TCP position and orientation to the robot. And it's doing the inverse kinematics on its own.
Yeah, exactly.
That.
Exactly. Yeah.
Okay. And when you send the TCP coordinates to that robot and it's doing the inverse kinematics, you just said there's some filtering algorithms on the robot itself. Is that implemented by you guys, or is it coming with KUKA?
They are not implemented on the robot itself. So they are also like other softwares and applications that you write them, like we write them, and they are on the robot's controller. So basically, when like each robot has a program, even if there is like, you cannot just like plug it into your v4 and then just run it. There is a program that defines like because it has like it's called KRL. That's the language, KUKA robot language, and so you can communicate through that. So basically, each robot has a computer by itself, which we call it robot controller. And then on that, you have different programs, and each program contains like different anything that is like called programming. So you can basically either send these smoothings already from the sender, which is in this case v4, or you can just have different smoothing algorithms and implementation on the program on the robot. So it's basically it's your choice.
And the communication, sorry, like we're going into details here and maybe I'm stealing time, but the communication between VV and the robot is probably some sort of a TCP open port or something.
Yeah.
And is that, like, I remember I was doing this many years ago with ABB robots, and there the main restriction was actually the speed of the communication port that has been running in its own thread on the robot machine. But there was some like real hard limitations, probably because it's chips from the 70s or something. I don't know. But is that an issue here with the KUKA, or is that super fast?
Well, I think like for this Pinocchio project, we didn't have any fast movements. But what I remember is like last year we had these robo drum projects that there were like 4 robotic arms playing a drum. So audience could go there and use a like one of these Ableton push and make a phrase, and then the robots were like moving very fast with the stick and hitting different drums, and they were like on full speed. So there wasn't an issue. Like the speed wasn't an issue, but also like there are a few things, like for instance the robot has there are terms, like for example there is something called singularity. It's like the robot, there is one position that the robot doesn't know which way to take to reach that very position, because there are multiple possibilities, and there are some position known as singularity positions, you know. And these are the thing that when you're programming a robot, you need to be aware of that. And they're like, I don't know, speed issues. For instance, if I move this ball from left to right, in this case, axis 2 at some point needs to have an infinite speed to accommodate the other axis in front of it. So basically that's something that is not going to happen, right? Because not all of the axes have the same velocity always.
Wow.
If that sort of answers the question.
Thank you. Yeah.
I've heard the saying that says, if you're the smartest person in a room, you're in the wrong room. I think I'm definitely in the right room right now. We have some comments for you, Amir, from Noor, which is actually my flatmate. She says, you should check out the work of John Lucy, a friend of mine, who is making some fantastic robotic arm similarly in digital and physical.
For sure.
Yeah, you might be familiar with this.
Thank you, Noor.
Cool. And yeah, incredibly impressive. I loved how you just started with the sphere and you just said, well, let's just add a robot to it. And that was quite a magical moment.
Cool. But I see in the end, like we lost the because that's out of the reachability. So we see this stuff as well. Okay, cool. I need to work on that. It was, I think it was not a good ending, but anyways.
Amazing. Any other questions or comments for Amir, either here in the Zoom call or through the interwebs? I think that was a really impressive thing. I think if you combine this with what Hayden is doing, God knows where we'll finish, right? It's very impressive.
You mean like scaling the robot arm?
Yeah,
While it's
like
moving?
making it bigger.
Yeah,
making it
but
run.
last year we did this. It was last year we did this super KUKA setup. So we had one of these Quantec, like one of the big ones, and then there was 4 small ones attached on the big one, and we were sort of playing. It was a dance movement that it was a dance piece that it was. I don't know if it's similar to Bonrako style. That these people that who are controlling a puppet, they wear black, and each of them holds one joint. So basically, each robot was holding one joint of a skeleton. And they were all mounted on a very big one. I think I showed that in November's meetup. But I think what do they say? Like, the sky is the limit? I don't know. This is stuff.
Hayden is asking if you imported the model as individual parts or segments, or is it a single?
Yeah, in this case, yes, because like for instance, for KUKA, we have the information of the of each joint. Like, there are information restored that how long is each one joint is, what are the limitation of each joint, and this data is also already coming from Inverse Kinematic from KUKA PRC. So we don't need to read it ourselves. It's already, the data is already there. We just need to connect the right link to the right inputs.
Cool. Well, thank you so much, Amir.
Thank you.
Impressive as usual. Okay, and I'll do the round of invitations again. If you want to join us, we are live on YouTube. You can find the link to the stream in our Element chat, also in the vvvv blog post for the meetup. And if you want to join us directly on this call, show us what you're doing or ask questions and participate on the actual live conversation, you can do so by joining us on Zoom. The link is also on the Element chat and on the blog post as well. So please do join us. We're happy to have you. And let's keep on going. Unless I see any volunteers, I don't know why my finger is pointing in Alvaro's direction. Yeah. So yeah.
Yeah, I must say that it was really impressive for me. It was super nice what we saw.
It's a pleasure.
Yeah, I'm going to show something less impressive, but I think nice for everybody. I will start to share the screen and screen 1, okay. Okay, can you see something? Cool. Okay, so I'm going to start really fast with just giving a mention to the Fresnel FX contribution that I'm developing, because tomorrow I will release one NuGet, so everybody can have it in the projects. You can take a look in the forum post. And I just prepared a little patch to make some fast stuff so people understand what they do, okay? Afterwards, we will move to the Megascans importer that is more complex, okay? But just wanted to show you that all the investigation was coming from this article from Unreal Engine, okay? That they show you what is the Fresnel in the materials and how they use it to make like a rim light for characters or to making other kind of effects. So the basics are like when the camera faces the object, only the normals that are in the borders of the object are glowing, okay? So with the help of Debian and starting to making some shader effects experiments, I realized that it's very, very easy in Gamma to create this kind of effects that goes on the top of a material, and then you can apply them to all the channels and all the different aspects of the material. So the code is pretty basic, and what it does is just the same, okay? We have here the balloon that it's reflecting all the time, and when we start to grow the exponent, we see that we are only getting this reflection in the sides, more realist than if you get it in another way. Another aspect that you can use it for to tweak textures too, you know, like in this case with the normal map, I apply it to a lerp and then giving two normal maps as an input, okay? And then if we compile the shader, okay, you will see what is the effect that we can get, okay? Just give a moment. I think it should compile because I just tested one moment ago, but I don't know, maybe it's like moment.
Well, you know, it's a live demo. chances of it
Yeah.
breaking are high.
Yeah, no, it was just working 1 minute ago. Okay, but if it works, let's pass to the next. Okay, let's see if this works, because we are going to see just in a fast way how to apply it to characters. But I think it's not going to work. Oh my god. Just
Feel free to start it again if you need to, don't worry.
Yeah, let's just, this is a fast demo, so I just wanted to show you in a fast way how it works, but if not, we'll move to the next one. So the important thing here is that I encourage every people to start learning a little of shader effects, because in this way we can create many different effects that apply to the material, and it's like the way it makes it really modular. You know, you can just plug this effect to one of the qualities of the material and getting really interesting effects to maybe later create like some kind of library with different aspects that we will see later. Okay, so let's try once again, and if not, we will move to the Megascans example.
One question for you while we load here, Alvaro. Is this using any of the new fuse stuff that Christian is going to show us later, or is this completely separated from that?
It's separated. I mean, it was like kind of research. I don't know what how they are doing it. It was just like an experiment to see what was the thing of the shaders in Gamma. So yeah, I don't know much about code, but it was just like taking in mind, you know, how the stride streams works. So it's really nice because you don't need to write many parts of the code. You can just pass, like I did here, the normal streams, the transformations, and the position streams, and then you can create your shaders, you know. So it's quite easy. So let's try for one more time. Okay. I think now it works. Maybe not.
Fingers crossed.
No, I think it don't want to work today, but it's okay. Let's in any case, you can download the NuGet tomorrow. Okay, take a look, because the example was very nice. I will continue with the other example that I hope it works, but okay, here we go.
Sure. And maybe after this we move on to the next person, but if you get it working during the length of the call,
we can leave it on the
show
last.
us at the end.
Yeah, sure. Cool. Because it was just a nice example to how to illuminate characters and all in Gamma.
Absolutely, yeah.
It can be very, very interesting. So we are moving to the Megascans, okay? And I don't know if many of you knows about what the Megascans is. Like Quixel, this nice company that is making scanners from many materials in the earth and many objects. And they are giving a nice library that it's free to use for Unreal users, but there are some free assets and you can purchase them too, you know, if you want. So it's very powerful material library where you can get many surface 3D assets and other stuff, okay? So I was investigating how, because there are many plugins that works for almost any software that use 3D. And I was investigating a little about it, okay? So I came across that they are using like JSON format. I mean, they have a JSON script, some kind of a script, and they load all the materials in this way, you know. So if you go to a Megascans folder, let me show you one of them, and you will see. It saves all the information about the textures and about all the material aspects in one JSON. So all the software, what they do is just receive this JSON by TCP and parse it, and then get the data in the respective places. No, so I start creating a UI for Gamma that is here. Here is it. Okay, so this is a way to communicate with the grids directly and import the assets in Gamma. So, and then you can just export these assets in an XML in a Gamma way with a DDS compression, okay? So if you set up grids, in grids you have like export settings, And in export target, you see that you have like many of the softwares, Unreal, 3D Max, Houdini, everything. So in this case, we're using a custom socket export, and you just set the port, okay? Then in the textures, you must be sure that all your textures are exported in JPG, because we don't have EXR loading in Gamma till the moment, okay? So once you are done, you come to the Megascans importer for Gamma, okay? You have here to set the port and to see that it's listening. And then let's go through some of the materials. Let's put this here better because I can see it from the other screen. So let's go a little through the materials. And let's say that we like this, for example, and you have here like a arrow to export. Okay, then you say export. It says that it's exporting to custom socket export, okay, and it's exported successfully. So automatically we receive in Gamma all the textures from this material, all the info like the name, type, tags, resolution, and all this data, you know, directly by TCP in Gamma. So now when Stride will compile, you will see the same material that we have in the Bridge software, okay?
This is massive, Alvaro. Wow.
Yeah, the thing is like all the textures are 4K now. You can go up to 8K. So it will take a little of time. As you can see now.
Look at that.
Yeah, we have imported directly the Megascans asset in Gamma, okay? And if you go to another one, okay, let's say I want this one, we just will export to custom socket, okay? And then we will load the textures and compile it, and we will have it here. So the thing is like here, what I did is just to parse the JSON and to get the data in a nice way, Gamma way. And I say, okay, why? I mean, in Gamma, it's very tedious to make materials and to share it with other people because usually they are patches that they have a lot of stuff different. But as these people do with making a convention with the JSON file and creating like kind of library, we could do the same and adopt this way and like to create a XML convention. So when we export this material, everybody could load it, as you will see now. So with exporter settings are based in another NuGet that I did not much time ago, that the name is, you can check it in the VIP section. There is like the TechSimp library, I think is here, okay? So it's like a DDS compressor based in NVIDIA Textures Tools. It's the only thing that I get working in Gamma inside, so I say, okay, let's go with that. So if you want to save and export this in DDS and with a custom XML that we can load later in Gamma, okay, all you got to do is to create a folder in your hard drive, like I did, for example, before. I have here Megascans drive, okay, and we have here all these folders that I created before. So here we will say that we want to save it in Megascans Stride, okay? And that's all. We will choose the quality. I will put it in normal to take less time. We could resize the textures and all the stuff. So let's process it and you will see what happened in the folder, okay? Okay, as you can see, it's starting to convert. It creates an XML, and now it's converting all the textures in DDS format that compounding material, okay? This will take a while, so if there is any question, we can move.
Sure, fire away. I mean, this is incredible. It's a full-fledged application already.
Yeah, I mean, it's not considered, but I think it's in the same way that we could create like kind of material editor for Gamma. So this is like kind of my first approach using another library, you know, but what is interesting is like, as I said, to create some kind of convention so everybody follows the same, and when we share materials, it will be super nice. And I will show later that we can do it too with 3D assets, because we are seeing now like material, but I will show you that the 3D assets are working too. Only the exporter is not ready now, but you will see that how it works. Okay, so it's converting all the materials, as you can see, in the format that I say, that is T5, okay, in 496, 496. So
Incredible.
let's wait. 2 more to go. Albedo, roughness. So the name of the XML corresponds to the ID of each material. By the moment, the XML is ridiculous. It's super simple, but I just make a little test. So now only includes the root of the textures in this folder, okay? But you can include anything. You can include the value from any of the parameters of the material. You can include the tags. You can include anything, okay? So it's ready. And then before we move to the loader, I want to show you that the 3D assets works too, but it still needs some exporter, you know, and some way to do it. So let's take this, for example, the most beautiful of all, and let's export it. Okay, we will see now that probably, yeah, here we go. So you should have here the same asset with all the textures loaded directly in Stride patch, okay? So the next step will be to include like the geometry information to can select the active LOD and to make other adjustments, but works so far so good. So now we want to make a gamma patch, okay, and to load this material from the material library that we create. I have an example here that I did so that you can see how it works, this kind of stuff. Sorry, where is the crazy gamma meetup? Okay, here we go, loading materials. Okay, and let's take this out one moment. So we start from zero. So what I did here is like just a little node that is a little not tidy now, not by the moment, but it will be more clean. That takes the XML that we create and just creates the material. So if we right click to select any folder from the Megascans Stride library, what was the last one I create? I think it was, let's see, yeah, all concrete wall. Okay, so let's open it and just plug it as a material. And now you have the displacement amount too if you want to take it. Now it will start to load. And let's put it in the, let's make another for the teapot in the asset. I must say that I'm in a laptop. Okay, let's go. So here we go. And let's put here in another one of the materials. Let's say, yes, this one, for example. Okay. I don't know, I have some errors there. I need to check it because I just did it today, but it's okay.
It works. That's
yeah,
awesome.
it works. Just some little stuff. I must say that I'm in a laptop that with a GTX 980, so maybe it takes time to load, or maybe it don't even load if it doesn't want. Okay, let's try this one, for example. Yeah, it should load, but it doesn't want to load. So let's try this one moment. Okay, this is working. So if I try here now, for example, this, no, this one. Okay, XML. Okay, it doesn't want to work, man. I don't have lucky today.
No worries, but I mean,
but
clearly it works.
Let's
see it worked already.
Okay, I think maybe this file is not taking. Okay, in any case, the idea is this. Okay, it's now a work in progress. I'm still in the first prototype because I really did it this weekend so fast, so I can show you something. But what is interesting at all is what I say is like the way that we can create material convention with an XML file and all the assets, so we can get easily sharing between us, materials, models, and all this stuff for a project, you know.
Hayden is saying you are reading the file instead of the directory, and that you should right shift click.
Oh my God! Yes, this is because I was nervous. I promise you.
Well, that's what we have. That's what we have people here who are paying attention.
Amazing, Hayden, you know. But now it gives another error. No.
What should we do now, Hayden?
No. Yes.
There we go.
Yes, there we go. Yeah. So yeah, the same. Let's check the rest of the materials to know that not again, to know that item was right. Mega scans is right. So for example, this another one. Okay, select folder. It's something with the XML reader I need to fix, but it will be soon. And now it's taking the textures. Okay, yeah. So. And the good thing is that all this is 4K, so the quality is really high, no?
Wow, man. I mean,
yeah.
We already have questions asking what the licensing model is for this. So I think you need to ship it and put a price tag on it and let us know, because already.
As I said, there are some free assets, and there are people that is like giving like points because they make a system of points. So for commercial projects, I guess that you should acquire some of the assets. But in any case, there are some free ones of surfaces and all this.
Oh, Alvaro, I think people are asking what the license is on your tool.
Oh, mine.
Yes.
Oh, mine.
Yes.
I didn't thought about that before. I mean, until now.
Well, the questions there. Have a think and let us know. This looks incredible, dude. I mean, not only did you make a full-fledged tool with a very nice user interface and all the features that you want, but you also made the exporter and the importer for us. This is crazy, man. Thank you so much.
Because in this way it's going to be more easy to work, right? If you import the JPEGs from the Megascan, so you can have just the format optimal for a Stride, you know. So
also what you were saying, like making a standard that people can use and that we can contribute with each other in a way that will work for everyone. This is a very important step.
It is very important, and for projects will be nice too. I mean, yeah. So if anybody has an idea to how to package our XML for Gamma, because as I said here, I just include a really simple XML with the reference to the textures, but we can put many more information, even like the roughness and like the metalness, anything, you know. So it's I think it's a smart way to do it, just with XML and something like that.
Cool. We have a question for you from Bjorn on the chat. He's saying, have you tried the DirectX TextNet NuGet for texture compression? He says he thinks it supports EXR. I have no idea what I'm saying here, but it sounds advanced.
I tried, but I didn't make it work at all with EXR, you know. So I decided just to do it with JPEGs, but it will be interesting to check other options to compression, you know. In any case, it's what I say, like the quality is really good for this stuff, you know.
Wow.
Because, yeah, it's very, and this is 4K. You could export it to 8K. So in this case, it will be more high quality. So
incredible, man.
Yeah, I hope you like it. I think we can, if there is any question more, if not, we can move on, and I will try to fix the other example for later if we have time. Okay.
Yeah. Let's do that. But before I leave you for now, is this already available then? Can people already download and use this?
Not yet, because it's just like, if I be honest, like all the UI I did it this weekend, and so there is much to clean in the patch and things that I need to really do it in another way. But it was just like for concept and for prototype, and to see that it works, you know.
Absolutely. No, I mean, amazing work. Thank you so much for taking this on, and take your time, clean it up, get it ready. I think a lot of people are waiting for it. We have some claps and things. I think you deserve it. We have many nice comments. Mega nice tool, looks so great and so easy to use. Pretty cool and useful. So yeah, dude, I think this is a massive win for the community, and we're very much looking forward to getting it on our hands as soon as you have it ready, man. Thank you so much.
I must say that it will be soon, because yeah, I'm doing it hard these days. You know, I will be patching, stream patching these days.
Okay, well, you heard it here first. It's coming soon to a patch near you. Thank you again, Alvaro.
Yeah.
If we don't have any more questions for Alvaro right now, I mean, or any comments or interactions from the Zoom call itself.
Fantastic work, great job. I'm really impressed.
Thank you, Amir.
Maybe meanwhile, until we know who would be the next person, be ready to be volunteer. Sorry, Randall, to disturb. I just have some breaking news, sort of like, have you downloaded the latest preview? It's a general question, not to Alvaro, to everyone. Have you downloaded the latest preview, and then have you looked into the help browser to see this fancy, beautiful, good old FX stuff? There is even a Liquish node there that you can run in a Stride now. So just go and see them. They are cool. They are really fun.
Oh, can hardly wait. I mean,
go for
first thing after the meetup for sure.
Yeah.
Amazing. All right, so
nice.
Thanks again, Alvaro, and see if
you
you can get the first demo working, and we can revisit it at the end if you fancy.
Sure.
Yeah, Christine is saying she wants this, so yeah, like you heard it here, it's gonna be ready. I think Alvaro said tomorrow or something. So yeah, looking forward to that.
One of these days.
Amazing. Yeah, okay, let's move on then. I mean, we have a new person who joined the call, Max. Welcome and thank you for joining us. We cannot see you or hear you, but I guess the general question will be, do you have something you want to show us today so that I can add you to the queue? Hello?
Can you hear me? Hello?
Now, yes, there you are.
Yeah, hello. Yeah, I'm here from Christine.
Oh, well, thank you for inviting your students, Christine. This is excellent. And do you have anything you plan to share with us today, or are you just here for the fun?
Sure, I can show you. I try to connect and hope that my PC is working or running this project.
We can give you some time to get ready and take someone else while you get prepared. How about, or unless you're ready right now, and we can just.
I'm ready. I'm ready to go.
Let's do it. So Max, let's see what we got.
I take the screen.
Mm-hmm. Just out of curiosity, what is this course you guys are in with Christine? Is it just general, like, what is it called? What is the course about specifically? Max?
Max is very bad.
Sorry, I didn't hear a car crossed by.
Oh, no, I was asking about this course that you guys have, or maybe Christine, maybe you can tell us a little bit about it. What are you guys seeing in this course that you're giving them? Anyone?
I can say a little bit. We start, I think, 4 months ago to learn a little bit or a lot of vvvv gamma with all the nuggets and all the stuff. And now what I'm going to show you is my final project. It's called Be Like Dr. Strange. And now if I type running, can everyone see my screen?
I see it. I think we're good. Yes.
Yes, awesome. Hello. Now again, I use the OpenTV nugget with and the Skia nugget. And I'll show you first, then I talk a little bit. I use also this. Does it work? Yes, here we go. It's
Oh, wow.
used with the Auku markers of OpenCV, like Doctor Strange and his magic shield.
Mhm.
Unfortunately, because of my webcam quality and my light, it's not perfect now. But here you can see I create this in a sphere, this magic shield. But also if you press off and on toggle, you have a little bit smoke effect.
Ah, nice.
Yeah, it's too dark here in my room. Yeah, and
Oh, but we get
it's
the
not
idea.
all
Very
because-
cool.
yeah, and a little bit of fun. You can of course change the color.
Mhm.
Yeah, and the reset button is just if the smoke effect disappeared too slow, you can just delete.
Amazing. And how long did you say it took you to get this up and running?
When I think it was, I don't know yet exactly how long it does take. At first, the good point was I learned from the Node Institute use the exams of OpenCV, how to learn how to use OpenCV buckets. It was very helpful. And yeah, I use this marker detection. I like this a lot.
Yeah, good to hear.
What maybe next time I'm gonna use is this, I don't know the name, it's the detection of the head. I don't know the specific.
Phase detector,
yeah.
I think it's called.
Phase
Yeah,
detector,
something like
yes,
that.
something like this. But this in combination with a hand, that I don't need anymore the Auku markers.
Ah, yes, you can do that.
Higher for this, maybe, I don't know.
Or maybe after you see what Kudi is going to show us today, you will switch the OpenCV approach for a machine learning approach. Let's see. No, very cool.
Yeah.
And what would you say has been your experience with this very visual programming, real-time interactive type of workflow?
It was very interesting. It's very interesting and very new. In my education, I learned normal programming like JavaScript and HTML and CSS, but it's like ABC, and now you have this connection. It's like, yeah, loudly called visual. It's a new way, but I kind of like it. It's easy to understand. And yeah, it's the result of 4 months now. And I'm very happy about it.
Amazing. And you have a really good teacher as well. So lucky you, I guess.
Yes.
Amazing, man. This is great. It's always very encouraging to see new projects and new people joining the community and finding their own way to use the tools and make what they want to make. Very nice. Thank you so much for sharing.
Yeah, of course. Thanks for being here.
And we hope to see your work upcoming in the next meetups, you know? This is just the beginning, as they say. Very cool, man. Any questions for Max? We have a thank you already. Very nice in the comments. Yeah, cool. Great job. Yeah, man. And also thanks for joining and sharing. That's amazing as well. Feel free to join us whenever. This happens once a month. So yeah.
Thanks.
All right. Cool. That was very nice. Very refreshing. I wonder if we should do another run at your second student, Christine, and take it to Han, because she said she had something to show us as well from your course. Hello again, Han.
Hey, yes, sure. I can quickly show that we want to save a lot of time. I guess there's still a lot of people that want to show something.
No worries.
Wait a second. I prepared my other screen for this.
And so would you say Christine is all right as a teacher? Is she very strict? Is she kind of cool? What would you say?
She's a really cool teacher, and we didn't have a lot of time, like only 4 months, but she tried to squeeze in a lot, as much as possible, so we could learn all about for Gamma. And she's a good teacher.
She's all right.
Thumbs up.
Okay. Cool.
Thank you.
I hope they're getting extra credit for showing this on the meetup, Christine. You got to give them something. Oh, wow.
Can you
Look at
see
this.
it?
Yes.
Yes, I was really interested in creating like this sci-fi hub thing, and I thought it would be also cool to connect it to some music. And I can show you. I used normal Skia and also incorporated some Elementor to add some effects.
Oh,
And
wow.
I can just start. Also, I hope you can hear the music through my other
Yep,
screen.
yep. It works. That's very cool.
Yes, and you can change the music, not the music, but the colors.
Kaboom, I see from the comments. Yeah, it's very, very stylish. I really like it. Reminds me a little bit
And then you
of
can reset.
something. Sorry, carry on.
No, I just wanted to say that you can also reset all the colors here with this button. And yes, that's pretty much it. I connected all the color variables to one place so I can change them with Elementor.
This is very impressive. And so this is on the same course. You basically had a similar amount of time as Max, I imagine.
Yes, that's true, and it's our first course in this with this programming language, so we never used it before. Yeah.
This is very impressive. I mean, I wish I could have been able to pull this off in my first 3 or 4 months using vvvv. This is super impressive. What would you say was the most complicated or the most interesting part of this project for you?
Wait a second, I'm just trying to stop this.
No worries.
Okay, I'm just on keyboard. The interesting part, can you repeat your question?
Yeah, I know, like, what did you find challenging or, you know, like fulfilling through this project? Because I know you tackled many things. You tackled like animation, 3D graphics, the camera movement, audio reactive. You had a UI with user interaction. So a lot of things to learn and to mash together. What would you say was the hard or the interesting part of it for you?
I think first time to write as a program like this in a visual way, because I'm the only language I know JavaScript, and I'm not used to code like that. So that was really cool and challenging. And what was fulfilling, I think, to see all the stuff that you do in real time. So you can see, oh my God, it's moving, it's something, I created something. So that was really cool.
Yeah, the immediate feedback. I'm super impressed with both you and Max's, and like David is saying, this is great proof that Gamma is, you know, a suitable jump into real-time programming, just as we had it in the previous versions in beta. And seeing new people coming from, you know, non-visual programming backgrounds pulling this type of thing in a few months is really amazing. Kudos again to your teacher, of course. And thanks, Christine, for inviting your students, and thank you guys for joining us as well. Very well done, Han. Bravo. I don't know if there's any questions.
And I have to you say I was a little bit afraid of teaching Gamma, and I thought beta is much easier because all of this type and format stuff is getting so complicated. But after I finished now the course, like all the students did really great jobs, and it was. Yeah, I was impressed myself. So yeah, it's cool. So I'm enjoying teaching Gamma, and it's, yeah, I mean, I love Gamma anyway. So yeah, and it's as well good for beginners. That's it.
Amazing, amazing. I'm sure the devs are smiling somewhere in the secret parts where they keep themselves. But yeah, that's amazing. Thank you so much again, Han. Amazing work, and Max as well. And let's see, what else have we got on the list? Maybe we take it to France with our dear and close friend Sebes Coudi and see what the machine learning world world is doing nowadays.
Sure. Let's see. Okay, so I'll start by trying to share my screen. Okay, can you see something?
It's blue.
I see a blue
Yeah,
screen, yes.
cool. That's my okay, so this is basically the first offspring of the machine learning initiative that started like 6 months ago. And for starter, we decided that we would try to get a pre-trained models runner in vvvv rather than creating your whole training pipeline and stuff. We just said, okay, let's find a way to run pre-existing models. And I tried to get ML.NET models running. So for those who don't know, like ML.NET is Microsoft's framework for everything related to machine learning, be it like traditional machine learning or deep learning for image recognition and stuff like that. And what I want to show you tonight is two demonstrations, like two examples of how you can start from just data and turn it into a usable model inside V4. For that, we're going to use a plugin in Visual Studio called AutoML. And this is like really magical. It's like super simple plugin that allows you with just a few clicks to create a model. And then we'll see how we can get that running in V4. So the first thing I want to show you is how you can create a model that classifies text. And when you want to train a model, you got to start with data. So the first thing you would do is like collecting some data. And here I already have a CSV made just for that. As you can see, it's like a plain CSV file that has like some like 4,000 text messages. And for each of those messages, it says, okay, is it ham or spam? Like ham means like normal message and spam means it's a spam message. And the idea is that we want to get a model that we give any message input and it somehow is able to figure out if it's a spam or not. Okay. So you just got to start with this data. And there's one thing that you got to do to help the vvvv node factory to work with the model is that you got to give special names to the columns. So you just insert a new line here and you have to say that this is the label column. Oops, made a typo here. Label. And let's say message, whatever. So once you've done this, you can save this and you can fire up Visual Studio. And we're not going to use Visual Studio, actually. We're just using Visual Studio for the plugin, but we don't need that. So create a new project. Console application, next, whatever. You can also do this on the command line, but I haven't tried yet, to be honest. So you got this stupid Visual Studio project, and it's actually really simple. You just say add machine learning.
Oh, wow.
And you get this like Microsoft style wizard where you have to click next, next, next. The first thing you do is pick a scenario. So not all of the scenarios are supported yet. They're just recommendation that I have not implemented yet, but it should work. And there are also other scenarios here, but they're not as easy to implement here. You're going to see what I mean in a minute. So the thing we want to do now is text classification. So you just pick text classification, wait a few seconds, and then you got a second screen that says, okay, next step, get your data. Okay. Get the data. SMS spam collection, and it's going to load the file for you. So you get a preview. And you have to say, okay, which column is the label? Which is the column that you want to predict? And in our case, this is the label column because we want to predict if it's a spam or not a spam. And the input column, the features are is just the message column. So pretty easy so far. Then you just click train. You say for how long you want it to train. It says 10 seconds, but we're going to give it a bit more, like 20 seconds. And you just click start training. And what's happening is that Visual Studio is going to try all possible algorithms and pick the most accurate one. And that's it. So you can see some output here. Okay, so it's trying this model, gives us an accuracy score. Cool.
Okay. So let me get that straight. So it's just going through the data with all of the different algorithms and checking which one does better.
Exactly,
picking that
because
one.
it
Okay.
knows what the output is supposed to be because it has the whole data. So it says, okay, tries this algorithm, calculates some accuracy, moves on to the next, etc. Here we just tried one model because we just give 20 seconds, but you could train it for like longer, and you would try different algorithms, and in the end, it would say, okay, this was the most accurate I could find.
Cool.
Okay, then you can say evaluate, so you can quickly see, you can quickly try your model. So we can try like something that is not a spam, like, hey, Randall, what's up? Oops. Predict. It says it's ham, so it's not a spam, okay?
Mm-hmm.
And what if I say you won $10,000? Go get it here, and there should be a link. Predict. Oh, it says ham. That's weird.
Oh wow.
Okay, so if you just say you want $10,000, it says it's a spam. Okay, anyway, the idea is that next you have to click code, and what it's going to do, and it's magical. You see, it added all those files here, and it basically generated a whole program that if you press play, you get it to work. But we're not going to do this because this is not what we want. The interesting part is that we got a path to a zip file, and this zip file is actually our pre-trained model. And this is the thing, like Visual Studio gives you a pre-trained model as a zip file, and that's it. So we're gonna try to get it. Right now I'm inside the zip, but I don't want to do this. Okay, I get the zip file. I can call it spam or not. And I gotta help the factory again by appending something at the end of the file. And this is a text classification. So I just say classification, okay. Then I'm gonna take this zip file, go to my documents, before gamma, sketches, get rid of this, I guess. And we create a new folder called ML models. We just drop the zip file in. And I'm going to save a new patch next to this thing, ML test, boom, next to this folder, okay. And the only thing I have to do now is just to go to the VL nuggets, download the nuggets first. I've already done it, but you should just go to manage nugget here. You would do nugget install vl.ml.net -pre because it's a pre-release, and it would install the nuggets. And when this is done, you just go there, blah, 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 ml.net, wait a bit. And then for some reason, oh, because I made a mistake. Classification. Okay. There's also one other issue here is that it's supposed to reload the factory when something changes in the folder, but this is something I couldn't figure out how to do this for now. Anyway, the idea is just that you click a bunch of buttons in Visual Studio, you get a zip file, you put it in the right folder, and what happened next? We're gonna see.
So if I'm getting this correctly, you're using Visual Studio to prepare these assets that we will later use in VL.
Exactly,
okay.
and they give you like this super easy thing where you just give data, it does magic on its side, and then it says, okay, use that. So yeah, this is what I think was really interesting, and this is what actually pushed me to develop this, because I say, okay, if it's that easy to create a model, then we should get something to run them in V4.
Absolutely.
Okay, so just saving this again, ML tests. And just if I reference the NuGet vl.mlnet here, I guess, yeah. Now you get this ML category here, and you get this node called spam or not. And this is the magic of VL's node factory feature that allow you to like, it allows V4 to basically like generate node on the fly. And I think it's like super incredible. And so we get this spam or not node that was just because we put this zip file here, and basically it's just the same. You can give it a message, you get this run pin, you get some output, the predicted label, you get even some scores. And if you say, I don't know, like, hey there, something that's not a spam, what's up? And you say run ham. Okay.
Wow.
So with 100% it's ham and 0% spam. What if we want to do like, I don't know, like you won like no dollars, Give us your credit card number! Exclamation mark. What is it? It's ham. Jesus.
Wow.
Okay, so it's not that accurate. What if we just say this? Okay, there it says it's spam, and you also get like the score. It says spam with 74% and ham 26%, and basically that's it. And if you want to get more model, you can also do like regression models are supported right now. So if you want to predict a value, like there is the classic example of the house value thingy where you get a huge CSV with house prices depending on the number of rooms and the number of steps of floors, sorry. And you could generate a model for that to predict house values. But the other cool thing is that they also allow you to train image recognition models. And this is fun. We're not going to go through the training actually because it takes a while, especially on this old computer. But it's also super simple. Like if you click image classification, the only thing you have to do is to prepare like folders, and each folder being a label of the thing that you want to detect. And the thing I've done here is I trained a little model to recognize patches. So it recognizes if you give it a picture of a patch, like a screenshot, it's going to recognize if it's like vvvv beta, gamma, or touch designer, or pure data, or XMSP. So let's see that. Just the training data that I gave it. Where is it? Download demo image. So you select the root folder. And it's going to say, okay, I have 20 pictures of beta, 20 pictures of gamma, 20 of max MSP, 20 of pure data, and 20 of touch designer. And it's the same. You would just click start training. It would process for like a few minutes. And in the end, you would get a zip file that I already have here, which is batch recognizer. Just call it batch recognizer. Put it here. And unfortunately, I have to restart v4 here because I didn't get this retrigger thing to work.
And so this node factory is creating a node that knows how to communicate with this train model just by the name of this zip file.
Well, actually, there's the node factory. It knows how to like inspect a model and retrieve all the inputs, retrieve the outputs. And basically out of this, it generates a node that contains just the function that calls the model, that calls like runs a prediction on the model. And it was really interesting. And by the way, I would like to thank again, Elias here for helping me on this, because really helped me, took the time to help me like cleaning things and optimizing things and doing some Visual Studio Voodoo. And like, it was really, really interesting process. Okay, so let's reload this. And we should have another node here. Yeah, patch recognizer. So here it takes a path. It wants a path to an image, run, and then a predicted label, also some scores, etc. And what we're going to do is create a path IO box. Okay. Convert it to string. Boom. Get rid of that. Enable Skia. Get an image reader so we can quickly preview the image in the patch. Okay. I got a few pictures on my desktop here. Let's take like a touch designer patch. Okay, what if we do this? I think, yeah, it recognized it was a touch designer patch with like good accuracy.
83%, yeah.
Yeah. And yeah, we can do this with gamma, for instance. What did it say? Gamma. Okay, cool.
Nice.
And so basically that's the idea. I mean, my first data, I did tests like to recognize cats or otters or dogs, and it was working just fine also. So I think it works surprisingly well, and the model is more smaller than I would expect. It's like 91 megabytes. So yeah, that's it basically.
And just out of curiosity, in terms of how long it takes to calculate this, is it something we could use in real time? Like, could I somehow patch a way to feed videos into this, and would it be able to do it in real time, or is it slower than that?
Like you mean, recognizing something?
Yeah.
I mean, no, once I think for the image one, I think the first run is a bit slow, but like I'm going to try a new image now, like a pure data, like if I click.
Yeah, it's almost immediate. Yeah.
Almost. And as for the other model, I think it's even faster. Spam or not. Let's give it a try. La la la. I don't know what it's gonna say about la la la. Anyway. Bang. How does it run? Yeah, it's almost in.
Yeah. Okay, very cool.
So I think theoretically, like for now, I just focused on running the models that were available with this like super stupid machine learning wizard thing. But theoretically, you could run all the models created with ML.NET, and I don't know. I don't know how to test this. I don't know. Like, if I should wait for other models to be supported by this plugin and then implement them, or try right away to use all the models. Yeah, I don't know what the next step would be. First thing, I would like to fix this like auto retrigger thing, because right now it's boring that you have to restart. But yeah, apart from that, it's cool. And when we're gonna have object detection running, this is gonna be cool.
Yeah, I can imagine the power of this thing, and also the ease of use to get your own data into a model, because this is, I think, kind of the more obscure or kind of mystical, unknown part for many users. Like, how do I get my model to recognize my object or my specific use case? And this is just very easy to do.
Yeah, I think they did something really cool with that. Like getting this like super simple wizard, just feeding the data, telling it what is what, and just run it. So yeah, pretty cool.
Amazing stuff,
I
Sevis.
found out that the hardest part was like cleaning the CSV files, really. And it can really be a pain, because like when you have like thousands and thousands of entries, like making sure it's all properly formatted, that was the most complicated part in like using the plugin, actually.
Okay. Well, I mean, Hayden says this is a beauty. Nor is asking if you're planning to use this in any particular project.
Frankly, no. But now that I know that it's available, maybe I will think about it. I would think about using it for the next project, maybe. But I don't really have a use case for now. I just
for those who don't know, Sevis, he loves making tools for the rest of us to use. So we will just add this one to the belt of things that Sevis has brought us. Pretty cool, says Ari Lasal, also Sevis. So yeah, people love this. They want to use this. It's already ready, right? You showed us the nuggets there. We can just download it.
It's already there with just this issue of the auto reloading, but otherwise you can just install and run it. And by the way, if you are running into troubles with it, like if I don't know, like if you try your own model and it's not supported, I mean your own custom model wouldn't be supported right now, but like I'm eager for feedbacks, like what goes wrong, etc. So even if you think about like new features or better ways to use it, like just don't hesitate to open an issue or shout in the forums or wherever, and I'll be happy to read that.
Absolutely. And for those who are interested in machine learning, there is an active machine learning VL element chat room where Hayden is there and Sevis is there, and some of the machine learning oriented minds in our community are there trying to push things forward. So if that's something that you'll be interested in, you can just ask on the main chat, or I mean, there's a way to find it, I'm pretty sure, but I wouldn't know how.
I'm gonna paste the link in the chat.
Okay, cool. And we're getting comments that also his workshop, and by his I mean Sevis's workshop on machine learning in the Node Institute is pretty good. So if you're interested in learning some more about this interesting topic, there's resources in the Node Institute for you to pick up from the top minds, as you can see. Any other questions or comments for Sevis? Looks like a no for now.
You need to show me how to make a factory. Well, actually, if I can answer Hayden's question.
Absolutely. Yeah.
Because Hayden says in the Zoom chat, like, you need to show me how to make a factory. Actually, I just had a look at the Runway ML nodes and try to figure things out. And I think like if you have a look at Fuse also makes use of that. So I'm not aware of any like official documentation for now, so it's just like reading the code and trying to understand which part does what and putting it all together and hoping for it to compile. But yeah, this worked.
And if not, you can just ask Sebes. He figured it out already. So there's your support.
No, but I think it's really powerful feature because like if you think about it, like you can do literally anything with that. Like if you have, I was thinking doing for web APIs, like if you have an XML that describes like REST APIs endpoints, you could like generate nodes instantly out of this, like all those sort of things. Yeah, I really like to get like more deep with this feature of the node factory and experiment with it because like I think it's really powerful.
We're going to have AI patching soon then. Is this the next frontier?
AI patching.
Yeah, you connect the node factory to some AI thing and it just makes you describe in text. I want a patch that does visuals, audio reactive in blue.
Yeah, I've already seen something similar with like AI text models like GPT-3 or something. Like you would describe a program and it would like generate a snippet. So yeah, maybe.
But that sounds, Seb, I think that sounds like a very cool webinar if you're feeling for like the node about Node Factory.
Actually, I've already asked myself this to Joreg like a few weeks ago, like please make a webinar about node factories. But yeah, I mean, sure, that would be interesting. That would really be interesting.
Yeah, I would be in for sure.
Me too.
Right, amazing. Well, thank you as always, Sebes. Amazing stuff. Thank you for keeping the lovely tools and nuggets coming.
My pleasure.
And I think we're getting close to the end, and I purposefully left Christian waiting all this time, hoping that the sun will come out wherever Kyle is at the other end of the world, and it worked. We have Kyle here with us, or yep, there he is, the man, the myth, the legend himself. Thank you for joining us, Kyle. And I think this is
some really cool stuff.
Yeah. This is the time for you guys. This is the Fuse team, what everybody wants to hear about. Let us hear what is going on.
Yeah, so maybe let's start with really like amazing stuff, everything that we have seen so far. Yeah, so really, yeah, hopefully keep up with this. Yeah, so we planned like give you a little update, and I will start by showing you some current progress on the computation pipeline. So we used the computation pipeline to implement some sort of particle system, but actually no, the nodes are far more generic. So it is not bound to particle system, but it can be used for any kind of computation. And the scope is still kind of limited to this particle system. We are going to extend it, but still it's useful for probably other kind of stuff. Yeah, so let's do some live patching. Hope that it works regarding yeah, the application and also my internet connection, which is with mobile phone somewhere in the mountains where I'm currently at in holiday. So in case anything crashes, don't worry, Kyle will take over and show you some other nice stuff regarding rendering.
Amazing. Just 1 second before you jump in, Christian, just for those who don't know, Christian, Kyle, and Nathan, who is not here with us today, are working on what they call the Fuse project. And this is a massive effort, I would say, on building GPU related library. What is this? What could we call it? Like the scaffolding or the basic tools that will be used by all of us, hopefully, in the future to build, you know, shaders and more GPU related goodies. But what they're doing right now is kind of building all the essential tools that we will need to build upon. And this is what we're going to be seeing. Did I do any justice to that? Yeah.
Yes, exactly. Yeah. So, yeah, let me share my screen, and then I show you some Fuse. Okay. Okay. So here we go. So you hopefully see a patch here. So first of all, I just managed with the help of Sebescudi and also Zabel to package everything into a nugget first time. So what you see here is not the GitHub repo anymore, but a NuGet, which I've just built like an hour ago or something. So while listening to all the other stuff here. So what you see here is like, if we go to dependencies via NuGets, it's basically here as vlfuse as a NuGet with this version. So with NuGet install, you should be able to get it from nuget.org. And yeah, jump in and also get into help patches. So this is all pretty alpha, but it should make it easier to just get a look into it. Yeah, so don't expect too much support, but if you're curious, want to play with it, crash your machine, enjoy. Yeah, so what have we done? You probably remember like the last presentation where shader graph, where Fuse was pretty much more like a functional graph. Yeah, so you had like inputs and you had functions and you could build some output. And for this computation pipeline, we built something on top. So now it's also kind of a resource graph, which is enhanced with metadata. And we use this to add attributes, which you use in compute shaders yeah, to actually store data and calculate with it. So what does it mean? It means you can create attributes. For example, let me show you like in here. Like an attribute like lifetime. So if we go in here, this is a defined attribute which belongs to a particle, yeah, and it outputs a shader graph. But this is actually no valid shader code or whatever, but it is interpreted by Fuse, and then there are resources created. So you see here, basically, there is a lot of more stuff going on. This is basically the emitter. So we have the velocity, the position, color, and all of the stuff that we know from a particle system. And then Fuse builds all of this together into some nice source code where you see you get a structured buffer of the particle. And it's not only generating the code for everything or the functional code, but also like the struct. So you see here, these are all like the attributes that we have created, and it creates a struct for this. And then it also creates the code on how to access and write to it. So you do not need to say, hey, I want to read some particle thing from a buffer, but this is all done for you. And so you can just use the attributes and patch with it. And then in the end of everything, so you see a lot of code because it's like forces and emit, and it's not really so much readable. But here in the end, it's then also written to the buffer and stored. And this is all like automatically updated for you. So you do not have to hassle with it, but you can just like patch and get the stuff pretty easily to work. Yeah, so what you see here is the output of everything currently. Yeah, so what you see here is we have some sphere random node, and yeah, you get in like a position and you get in a radius, and then it gives like the particle emitter a position where it emits the particle. And then it also gives a color. So what you see here is, okay, this is a random value, and then it's a HSV to RGB. So this is how we get this kind of yellow-orange colors to everything. And yeah, what we're going to do now, we do it live, is to add some force. So pretty basic force would be a gravity. So we could just add a force node, put it into the graph. So now you see the graph is updated. Yeah, so we have no visual. There our visual is back with some weird value. So we create a GPU in. And basically, a force node can be used for anything. You basically need to provide a vector 3 value, which can be calculated from anything, and this will then be the force. And now we just add some X direction, and now you see everything is updated as we go. And another thing I want to highlight is like probably like how you work with these attributes, like maybe to create another custom force here. So something that comes with the particle system already is a target attribute. So we create a new force, which is target related. So we use this target attribute, and we use the position attribute of the particle. And now we subtract those. And this now creates a force vector. And we might also want to have some strength value. So the GPU in gives us the possibility to control this strength, which is the second value here in force. And now we plug this one into a particle system. So it's again recalculating the graph. And what you see now is that the particles move towards the center, which happens because the target is set to 0. And so this is why the particles move there. And what you can do now is you can extend the emitter. So basically, everything that happens in here, we can do with custom and other attributes as well. So we do this with the group node. And this one is put in here. So this is all happening like pretty quick now. So I don't go too much in detail, just try to show you what is possible. We will definitely have like webinar or something like going in far more detail on everything like this. What you can do now is you can set the target on emit. There's a set value for this. And you plug the target in there and in there. And now we take another GPU in for the target. And we have some value here. What you see here is basically, I directly control it with one value, but of course you could also put in like other compute operations in there, like random or read from a texture or something like this. So it can be a far more complex graph than what I'm doing right now. Now you see when I move the target over, you see that the particles follow. Right? Okay, so pretty simple example, but everything that happens behind it is actually, yeah, was hard to get to. It was really like hard work to make all this happen. And that's why it was also quiet a bit on the chat and everything. It was like sometimes really hard work and frustrating. And I was like really hoping so hard to get to this point where this would be working. Yeah, and then like one last thing is like now what we want to extend, and what I want to show you is how to work with custom attributes, and also that not only the simulation is controllable with these attributes, but also the rendering. So we can use the same attributes to actually say how the particles should be rendered. And what we want to do now is we want to add an attribute for a second color. So I now create a completely new attribute, which is not part of the pipeline. And I call it color 2. And basically, I just take another attribute like this as a template. So basically, probably better take the color attribute because it already has the same as the correct type. Now go into this process node. Put this in, give it another name, so it's color 2, and make sure that the shader graph is also updated or set out in the process node. Go back to particles. Now we can use, looks quite messy here, my graph. Let's see. So now we set the color 2 as well. Take another set. This out. This in here. And we use basically the same operation like this. So this is probably something that could go into another node to make this more readable. We have some inputs there. Like this. So now we should have a second color. Let's see. Wait till everything is rendering again. Okay. So I hope this works now. So basically what we can do now, as you see here, this is our rendering. Yeah? And there we are already using other attributes, for example, like age over lifetime. So here inside this one node, we use the age and the lifetime of the particle to actually give us a value from 0 to 1. So this would be like one example on like how you can put like more smarter nodes for operations on particles. And if we go back in here, so now we have the lerp, and we put in the color, and we put in our second attribute, the tool.
While you're showing us, Christine is asking, what you're doing is basically writing a shader through patching.
Yes.
And yes, yeah.
Exactly. Yeah. It's not working like this. So basically what happens here is I get a normal float from here, which I cast to a vector 4. And now let's see. Now the shader is recompiled. Everything works correctly, which it does not. Probably have messed something up here. Let's see. Yeah, maybe not spend too much time on debugging here. I have another patch where it is working. It should work. So we close, just open, and probably to end this, and maybe some questions or Kyle could take over. So.
I mean, people are already saying that this looks insane. Christine is saying, oh, when I wanted to learn shader programming, and now she doesn't need to. You know, she can just use your nodes, which is a lot better.
Yeah, so here you see actually what the example should do, right? So it's going from orange, red to like blue. Yeah, with what we're doing here, like we have a mix function, and yeah, basically one color is going to the other. And then just to end this, if we look at the code now, I mean, you might just remember how it looked before. So you see that everything is generated on the fly. And yeah, like here in the particle struct. So here we have this new attribute end color, which wasn't there before. Yeah. So it's really like you can do it everything dynamically, and you do not need to touch this shader and those resources, and like update everything there, create new nodes for this, you know, to write something in the shader. So everything is connected like in this one graph and built for you. And as you see, it's like really fluent and quick to do this stuff. Yeah, so you can just take your custom attributes, you can add a noise. We will also make sure to add SDF and other operations on it, or like maybe get from Hayden's skeleton, get the skinned mesh and get those data in there from a buffer, so that you can use this one for forces or for emitting. I mean, we really now kind of have finished this and are like really on the boundaries to make this like more integrated into the full Gamma pipeline, so that you can use it for all kinds of stuff and be really performant and make it easy to do those things.
Looks amazing. And we just got the NuGet install command posted here in the internal Zoom chat. I'm going to post that on the Element chat as well for those who want to give it a spin. Again, like Christian said, this is alpha, so, you know, expect some quirks and issues, but, you know, I guess the idea for now is for people to test. Yeah.
Yeah, and one more thing to this. So I think we now hit a stage where we will use it in our projects internally, so which makes it for us easier to not only work like on 2 different construction sites, but actually make it one. So while developing a project, also develop Fuse. So that will speed up things, and yeah, will us allow to add more nodes and make everything more stable. Yeah, without giving you the hassle, hopefully. But get us through the hassle first of missing.
I'll mention a little bit more about that.
Yeah.
Amazing stuff.
Yeah.
Yeah.
And, yeah, before maybe Kyle takes over, so we really plan like to continue like for the next like 2 months, really getting forward, getting more nodes, make it more usable, making more demos, extend the rendering and everything. So I think we really got now like the quiet part, which happens like under closed doors, kind of. Yeah. We got pretty far with that, and we're probably going now to open this up into more useful scenarios. Yeah.
Yeah, I think from an outside point of view, you'll see a little bit of a exponential increase in the output from it. And it's not that we haven't been very busy with it, but a lot of the stuff is more kind of the low level stuff and making the systems that we make the systems with, and not the kind of sexy things, but it's really amazing. Like the demo Chris has been giving, it'd be already quite nice just as a particle system, but like all of the same infrastructure can use to make all kinds of things. Yeah.
And the cool thing is it really works like with all the previous fuse nodes we did. Yeah, and it took a bit longer, but the cool thing is that thing is like really is completely integrated. Yeah, and we really wanted to give you the full flexibility to actually build as much as possible. And that means to not only make some pre-built nodes working for a particle system, but allow you to patch those nodes yourself. And that took a bit longer, but I think in the end, creating new nodes and extending the system will be much faster and more flexible.
Amazing. And I guess before Kyle takes over, are you guys still receiving donations? Is that still happening? Should people still be sending you money to help this thing come through? What's the story there?
Yeah, sure.
Always welcome.
I mean, you're always welcome. But we always, again, like, let me say this first, it's like really, we're really thankful for the support, and it's really motivation. Like, it's really when you hit like the second day and you don't get forward because you hit like a wall, and it's something like, fuck, I'm tired of this, then it's one of those things, where you say, like, come on, let's push it. There are people waiting for this, as you are. I mean, because we want to get this thing working to play with it ourselves, But of course, this is like a nice reminder. Okay, there are people supporting us on this, and waiting as we are. So, and it is pushing like probably like another late night, to get this out.
It's highly motivational. Yeah. Well, there you have it. If you want to help with the Fuse project, there are ways for you to do that. Tevian just posted the chat room link on the main Element chat if you want to join there. There's also a forum post with all the details of what the project is about and how to donate and get involved. But let's see some more. Take us through it, Kyle. Okay, give me a sec just to set up a screen share. Well, I'm kind of sleepily fighting with Zoom. I'll just say again, a very big thank you to the people who've helped out already. And also there's quite a few people who put their hands up for like testing and helping with documentation and just porting nodes from some of the beta libraries to Fuse. And looking forwards to kind of bringing more on very soon for that. We're still kind of just trying to get our ducks in a row. We say in English, I think you can extrapolate, just to make good use of that. But let's see, I forgot. Can you guys see something? Yep, lots of spheres. Yeah. Okay, so this is just kind of a small patch, but it's a little render feature. Pretty happy with. These are imposter spheres. So like obviously for lots of things, drawing spheres is nice. It's the circles of 3D.
but to draw kind of nice ones, when you're using meshes, the vertices really add up, you know, as you put the kind of smoothness up, and especially when you're drawing a lot. So this one's kind of doing a little bit of kind of tricky magic inside the pixel shader, where basically they're ray trace spheres. So if you go in really close, you'll see like there's just you don't have any of the kind of sharp edges you'd get with a mesh. So that's kind of a cool thing. But what really makes this nice is that from the engine's point of view, it's really it's in that world. It's treated the same way it would be if you were using meshes, which then lets us, you know, use things like ambient occlusion, all of the lighting and material from the Stride engine just kind of works with them. And you can see just kind of like turning those on and off. It makes a big difference. And it's pretty performant. So like while I'm talking, I've got this little thing here that's just going to be able to, each time we increment that, we'll double the spheres in our scene. So at the moment, it's kind of got the whole thing in a for loop. I'll show the actual imposter in a sec, but so we're running that kind of 8 times in parallel, and at the moment, each time we'll draw 500 spheres for 4,000 spheres total. So we'll have a look in the patch. I'll just double it again first. So now we're drawing 8,000. So this bit at the top is just kind of doing some positional wrangling. It's making kind of random spreads for the positions and the radius of them. That's kind of all stuff that we would do actually like with compute shaders and stuff, just to make the inputs. This isn't actually like a module yet. It's pretty much ready to be turned into one. But yeah, the cool thing is that we basically will have like all these inputs you would expect for drawing spheres, but then it's really up to you how you render it, because it's basically at the end it's just another entity in Stride. So you can actually just have like a material input, and then you can connect any material you like to that. What that also allows is that we can, if we want to patch our material, so here's like, you know, usual suspect, just a little bit of noise to sprinkle on. I can just have that input and it'll override kind of whatever is on the default. And so, yeah, you can see now that's updated. We should go back to the top patch and maybe start doubling again. More. So yeah, I'm drawing them like with a fairly large radius here, so there's a fair bit of overdraw. So like it's fairly demanding. And one thing I'd mention that's nice is that, I mean, the code for this is not super optimized, but it's been nice to implement it in Stride and see that it's actually been a lot more performant than the same thing would have been in beta. Oh, wow. So for example, now, you know, we've got 30,000 there, and they're quite large, and there's a lot of overlap between them, but we're still at a very steady 60 frames a second. And we can actually just keep going up, and that's not really impacted. So yeah, we're at 100,000 now. And it just doesn't really care. Let's double it again. Double it again.
Careful while trying this at home. Your computer will crash eventually.
Okay, so a brief dip in the frame rate there, but actually that's mostly just because it was having to wrangle some stuff from the CPU to the GPU with the way I've set up the patch. But you can see now, like have like 1 million on screen, so there's quite a lot of overdraw, and we're still at 60 frames a second, which is nice. And plus, it's running kind of procedural noise for the material. We can maybe spread them out a bit more. Yeah. One thing that's kind of interesting, the way this is actually being done, is it's sort of hooking a little bit into Stride's material system, and that's what lets it work and be integrated with like all of the lighting from Stride and everything like that. But the process of setting that up has also kind of opened the door for being able to do other things. One thing we haven't done yet, but have been talking about as a really good use case of this compute system that the guys have set up, is that we can also use it for like a geometry pipeline workflow. So that will basically replace geometry shaders. And what that means is the way you make geometry is just a lot more free and doesn't have the same constraints that the formatting of a geometry shader has. So you'll be able to also kind of patch effects on meshes, and then stuff like this where it's kind of like smoke and mirrors, so sphere imposters or ray marching, you'll be able to kind of mix and match with those more traditional techniques as well. So that's pretty exciting. Chris kind of mentioned, I think, on the side before that we actually have some project work coming up where we'll be using Fuse. So there's actually like several studios that are like already kind of getting ready to use it in production. One particular I'd shout out is we've got a Rafik Anadol one in August, where we'll use Fuse for kind of a large semi-permanent install. And we actually have the 4V devs on board for that as well. So I think that'll be kind of a good collaboration in its own right, but it will do good things for Fuse as well in terms of making it a little bit kind of battle hardened or trial by fire or whatever you want to call it. Yeah, so, and that kind of lines up too with I think August is when we're looking to kind of actually have a kind of version, like a first version ready for release as well. I'd say thank you again to Sebastudi and Sebel for helping to set up the nugget. So I mean, you can grab that now, but just be aware that like it's still changing and we're not kind of really at a point of supporting it necessarily. If you're brave, please do check it out, but just bear in mind it's still kind of pioneer days with it.
Yeah, for those watching on the stream, of course, bear in mind that what we're seeing has a massive lag because of YouTube and whatnot. But if you try it, and we're getting comments already on the chat, if you try yourself on your machine with the Nougat, it's just 60 FPS lock.
Yeah, and the next thing is, of course, to get the particle system joined with the sphere imposters. So it's like we're working independent on various construction sites. But as I said, we're short before like bringing it all together.
I mean, this is massive, guys. Wow, it's looking great. I mean, every time you show us something, it's amazing, but you know, it's needless to say, it's amazing. Yet again, very exciting. And performance looks crazy good as well. I don't know, people, comments, wows, claps, anything.
Yeah, maybe one last thing, like what Kai just patched there is of course also the fuse, like the noise coming in there. So maybe like if you just move a bit over, Kai, so to show us the noise input on the material side. Yeah, there. So there is like a 2 shader FX node, what you see there. So for us, it's important like to get really nice interfaces also into the sphere world, into the Stride world. Yeah, so we're currently thinking like how to make the rendering flexible, how to get data in. So that will probably happen like also over this 2 shader FX nodes and also about buffers. This might be put into other nodes as well, so that you do not need to hassle with it. But that it's easy, for example, also, if, for example, Haydn's skeleton work comes out, then he does not need to get into Fuse World or whatever, or we need to define an interface for it, but he just needs to make sure to put out in buffer or whoever is doing anything. And also out of Fuse, you can get buffers. So you can do all the calculations, get the buffers, and then put them somewhere else.
Nice.
So this is also something we're looking into more carefully now on how to communicate with other libraries.
Yeah, this is massive because in the past with beta, that was one of the main issues we had. No, many bright minds building their own solutions, but when you wanted to get different libraries to work together, it was really painful. And what you guys are doing here is massive in that front, I think.
Yeah, that's not always possible, but whenever someone would come with suggestions, you know, that we're definitely open for that, to open stuff up when we don't see it ourselves.
Amazing. Any questions, comments for these guys? Aside from all the congratulations and positive comments that I'm seeing all over. All right. Well, I think. Oh, we have one incoming. Says, is the imposter shader written with Fuse?
It's partly. It's at the moment not so much, but that's kind of what's changing a little bit at the moment. The reason for that is kind of twofold. One is basically I shouldn't have stopped sharing. Basically, the way that it's currently overriding parts of the Stride engine, you kind of have to call like a file from disk and use that as part of the shader. And it's also doing a very simple geometry shader to make like the quads that it's drawing the spheres on. So at the moment, those two things are things that you couldn't patch, but we're kind of already on that. Like basically we're replacing the geometry shader with a compute approach. And then you could patch exactly what the kind of quad logic is doing. And for the part where it's overriding part of the engine, at the moment that's from file, but it's already kind of been trained that will have like a graph input basically. So you'll be able to patch that as well. Yeah. So the short answer is the example here, which is kind of in the R&D folder, is actually from code, but kind of needed to do it that way to figure out how to make it all work. And it really was like only yesterday, I think, that this version was actually functional, was still kind of debugging some things. But in the future TM, yes, you'll be able to patch that completely.
What's this, Hayden? Fancy writing a vvv a night. I'm not. He must be referencing something I'm not familiar with. Nanite. Ah, I see. Yeah, I mean, who needs Unreal, right? We can do everything with Fuse.
It looks like very impressive technology, I have to say.
You know, I like the fact that Gegenlich is already like he's doing his stuff and he's posting a screenshot on the Element chat. It's really cool.
Yeah. Somebody run it on a really relatively old GTX 1650, so fairly old. The particle system demo, and it's running 60 FPS like it's nothing. So yeah, amazing performance also even on pretty old hardware.
Yeah, we're looking into it. There's more checks, and like honestly, while I was working on it, like my GPU was smashing like every 15 minutes because I had some buffer issues and DirectX was crashing. So yeah, happy to iron those one out, but it was pretty nerve-wracking on the way. So and if this happens, okay, please be gentle. Those stuff will probably be ironed out on the way.
All right, amazing. All right, guys, well, we've extended ourselves a bit more than we were intending to, but it's being properly justified through and through. Christina says, goodbye. Gamma will be big. We're changing the world. I think she's right. Hopeful and big, inspiring words. Thank you, Fuse team. It was amazing what you showed us. Thank you, Kyle, for joining us. I know it's early or late for you, wherever it is you are. And I mean, we saw some amazing stuff. Let me just do a quick recap. We had the Fuse team show us their amazing progress. It's looking amazing, and you can try it at home yourself with this alpha nougat. So please give it a spin. Keep in mind that it's alpha and it might break. So just keep that in mind. We saw Alvaro showing us his amazing tool to import all this amazing textures. Oh, by the way, Alvaro, did you get your other demo working?
Yes, but I think it's not much to show. It's just that the people remember that to check the BL Fresnel nougat that I will upload tonight. And just it's a nice tool to play with materials and get some nice effects, you know?
Amazing, yeah. So keep your eyes open. Tomorrow we have a new nougat coming in from Alvaro. This amazing tool that you saw will be dropping soon as well. So thank you for that. We saw Hayden's impressive skeleton-oriented work that will probably be merging with Fuse in the near future. We saw Sevis QD machine learning extravaganza, very amazing and promising stuff as well. Amir showed us his incredible inverse kinematics robot management solution. We had Ham and Max from Christine's class as well, showing us what new students can do with Gamma with a little bit of time. So I think it's been amazing as a meetup, amazing stuff all over. Thanks everybody for showing their stuff, for joining us and sharing. And thanks everybody back home for joining us as well. Any parting words from our panelists in the Zoom call?
That was a blast. Thank you, everyone.
I have to agree. And if that is all, it's been a pleasure. And Amir, I think it's in your hands to take us off the air. Goodbye.
Bye, guys.
Ciao. Bye-bye.